Welcome to AI Frontiers. Today's episode, titled Trustworthy AI, The Next Leap in Computational Linguistics, spotlights the most recent advances in language understanding and generation. Drawing from 90 cutting-edge research papers in computational linguistics, this session focuses on reliability, reasoning, and inclusivity. The discussion will highlight core themes such as faithfulness, efficiency, and transparency, providing a comprehensive journey through the state-of-the-art and illuminating the future directions of the field. This presentation will chart the current landscape of artificial intelligence in language technology. The talk will unpack dominant research themes in computational linguistics, spotlighting key advances in faithfulness and interpretability. Influential papers and their broader impacts will be highlighted, followed by an exploration of methodologies shaping contemporary research. Finally, a glimpse into future directions and the societal implications of these technological advancements will be provided. Computational linguistics is the interdisciplinary science at the intersection of linguistics, computer science, and artificial intelligence. It powers real-world applications such as digital assistants, translation services, and information search, enabling computers to understand, interpret, and generate human language. These models facilitate nuanced communication between people and machines, allowing for more natural interactions. The field's influence extends to societal concerns, including the accuracy, fairness, and trustworthiness of information disseminated by AI systems. A foundational theme in recent computational linguistics research is faithfulness and trust in language generation. Reducing AI hallucinations, which are inaccuracies or unsupported information in generated text, remains a critical challenge. Notably, Huang and colleagues demonstrated that span-level fine-tuning substantially cuts down on these inaccuracies, enabling more granular evaluation through new datasets. The pursuit of trustworthy artificial intelligence is vital for domains such as news, research, and broader societal applications. Ultimately, faithful generation is the bedrock upon which reliable communication is built. A second major theme is reasoning and chain-of-thought modeling. Modern language models are increasingly able to explain their reasoning processes step by step. For example, the mind-paced speaking framework introduced by Zhang and collaborators employs a dual-brain approach to real-time reasoning in spoken language models. White box verification techniques are now exposing the logical pathways taken by AI, providing greater transparency in language model decisions. Such advancements are pivotal for interpretability, especially in high-stakes domains where understanding the rationale behind model outputs is essential. Efficiency, societal impact, and multilingualism form the third central theme. The escalating costs associated with data and energy consumption in large models are being addressed through innovations in model design and training. Pan and colleagues illustrated how masked diffusion models significantly boost data efficiency. In parallel, Wang and associates developed methodologies to expose societal biases in AI, promoting safer and fairer systems. Meanwhile, Kim and team utilized synthetic data to advance multilingual capabilities, showing that efficiency gains can enable broader and more equitable access to AI technologies. Evaluation, benchmarking, and collaboration are the fourth theme. The field is witnessing the emergence of new benchmarks that assess narrative and reasoning quality, with judge models, such as those explored by Li et al., aligning machine assessments more closely with human agreement. Collaborative generation, as exemplified by Feng and colleagues, orchestrates model synergy by leveraging multiple checkpoints for improved performance. Hybrid symbolic neural approaches are also gaining ground, combining the strengths of both paradigms. These evaluation frameworks are essential for driving meaningful progress in language technology. Several key findings have emerged from the analysis of 90 recent papers. Span-level fine-tuning, as demonstrated by Huang et al., sharply reduces hallucination in generated text. Switch generation, introduced by Feng et al., repurposes intermediate model checkpoints to achieve synergistic performance gains. Mask diffusion models, explored by Pan and collaborators, close efficiency gaps that have historically challenged large language models. White box verification methods, such as those developed by Zhao et al., reveal the underlying logic of model reasoning. Finally, Kim and team's use of synthetic data has enabled the development of robust multilingual models, extending the reach and utility of language technologies. Today's models improve through a variety of sophisticated methodologies. Fine-tuning with targeted supervision, whether at the span, trace, or domain level, guides models toward desired behaviors. Reinforcement learning is employed to optimize for nuanced objectives, such as reasoning quality or safety. Hybrid symbolic neural architectures are increasingly used to tackle logical inference tasks. Data augmentation and prompt engineering remain prevalent strategies for enhancing model robustness, particularly in low-resource settings. The integration of white box and black box evaluation methods provides a deeper and more comprehensive insight into model functioning and performance. The highlighted paper Enhancing Faithfulness in Abstractive Summarization via Span-Level Fine-Tuning by Huang and collaborators addresses the persistent issue of hallucination in automated text summarization. The authors employ span-level supervision using GPT-4o to automatically label unsupported spans within summaries. Unlikelihood training is then applied, penalizing the generation of hallucinated content. This approach yields significant and consistent improvements in faithfulness across multiple evaluation benchmarks. The introduction of an open dataset with span-level annotations establishes a new standard for research and evaluation in summarization. The seminal work Don't Throw Away Your Pre-Trained Model by Feng and colleagues introduces the switch generation framework, enabling collaborative model response. A dedicated switcher dynamically routes segments of input to the most suitable model, harnessing the unique strengths of both pre-trained and aligned checkpoints. This method consistently outperforms single models and traditional ensembles across 18 datasets. By repurposing intermediate checkpoints, switch generation boosts efficiency and paves the way for more adaptable and resourceful language systems. In closing the data efficiency gap between autoregressive and mask diffusion LLMs, Pan and colleagues systematically compare autoregressive and mask diffusion models. The study finds that mask diffusion models excel in data efficiency, particularly when injecting new knowledge. The introduction of masked fine-tuning allows current autoregressive systems to achieve similar efficiency, reducing the need for extensive data augmentation. These findings challenge the dominance of traditional language model paradigms and suggest a more efficient path forward for both researchers and practitioners. Looking ahead, several future directions are emerging within computational linguistics. Interpretability and transparency are becoming essential features, enabling stakeholders to understand not only model outputs but also the underlying reasoning processes. Collaboration is expanding across models, symbolic logic systems, and human experts, yielding richer and more robust AI solutions. The drive for multilingualism and inclusivity is broadening AI's reach. While energy and data efficiency remain critical in light of environmental and economic considerations, ongoing attention to ethics, bias, and societal impact will continue to shape research priorities and deployment strategies. The synthesis and review process for this presentation leveraged advanced AI technologies and expert oversight. GPT 4.1 from OpenAI was utilized to synthesize insights from numerous papers and to structure a coherent narrative flow. TTS synthesis and image generation, supported by leading platforms, contributed to the production. All synthesized content and references underwent thorough review by human experts, though some oversights may persist. For comprehensive details, refer to the cited references. This multi-stage approach was designed to ensure both technical depth and accessibility for all listeners. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so listeners can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thank you for joining today's episode. To stay updated on the latest in AI and computational linguistics, subscribe to our YouTube channel and join our community for discussions and expert insights. All referenced papers are available in the show notes. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.